All right, guys. So as you probably know from our DICE investigation, we are going to be talking about probability in this next unit. And I wanted to start off ending up this first week with a bit of probability review. So let's work through some problems. So number one, we got Bao owns a small business selling used books. She knows that in the last week, 20 customers paid cash. So 20 paid cash, okay. 26 customers used a debit card. 13 customers used a credit card. Okay. Based on these results, express the probability that the next customer will pay will pay with a debit card as a percent to the nearest whole number. All right, so what we do here, basically, probability. Or the probability that event A will occur is literally the amount of the expected outcome that you want over the total possibility. Over the total possible outcomes. So what does that mean? In this case, we've got 20 customers paid in cash, 26 customers paid with a debit card, 13 paid with a credit card. So that means that there were 59 total customers. So that the probability that the next customer will pay with a debit card is going to be how many customers have paid with a debit card divided by how many total customers there have been. So the probability of event A happening would be 26 over 59, which we can just plug into a calculator, and you get 0.4406 and some odd change. Now we want to turn this back into a percent, and we want a percent to the nearest whole number. So basically you just move the decimal place over 2 spots to get it back to a percent, and you end up with 44% chance that they will use a debit card. Yeah, so 44%. All right, let's do another one. An apple chew was, okay, let's see. Emily has a bag that contains apple chews, cherry chews, and peach chews. She performs an experiment. Emily randomly removes a chew from the bag, records the result, and returns it to the chew bag. Performs this experiment 53 times. Her results are shown below. Based on these results, what is the probability that the next chew removed from the bag will be an apple chew? All right, so we look at the number of apple chews, which is 46. And then we need the total outcomes, which in this case would be 53. I actually told that up here, but if you add those up, you get 50. So 46 over 53, right? We're gonna plug that into our calculator. I'm getting 80, I'm getting 0.86, 8 if I round up there, and we want to do the percent to the nearest whole number. So this would be 87%. So that's what we'll put in there. Awesome. Part 2, the probability. Let's see. Michaela has a bag that contains orange chews, cherry chews, and watermelon chews. She performs an experiment. Michaela randomly removes the chew from the bag and records the result of the chew from the bag, performs the experiment 50 times. The results are shown below. Based on these results, express the probability of the next chew from the bag as a fraction in simplest form. All right, so basically we're just gonna have to reduce a fraction this time. Should be still pretty simple. In this case, we are asked what is the probability that it is an orange note or a cherry. All right, so there are 14 times we got an orange, 12 times we got a cherry. So if it's an orange or a cherry, it would be 26, right? Because if of the 50 times she did the experiment, she got a cherry 12 times, orange 14 times, then total between the two of them is a 26 out of 50 chance. And I'm just adding those two together, right? Because it's or, and most of the times when we think about or, we mean and plus, right? So it'll be 26 out of 50, but we need to reduce this fraction. Both are divisible by 2, so you end up with 13 over 25. So the answer would be 13 over 25. And you can see in this case, orange or a cherry. In a popular role-playing game, players create detailed designs for their character, costumes, or appearance. Oliver sets up a website where players can buy and sell these costumes online. Information about the number of people who visit the website and costumes purchased on a single day is as follows. Okay. In the next week, he is expecting 900 visitors. About how many would you expect to buy more than one costume? Round your answer to the nearest whole number. So basically, in this problem, the first thing you want to do is you want to find the probability of your outcome. And then what you're going to do is you're going to take that probability and you're going to multiply it by how many, I guess your sample size, I guess. This is how many people you expect to happen in the future. In this case, our sample size being 900 video visitors is what we expect to happen in the future. It was a lot like in the problem, the investigation, when we took 1/6 and multiplied it by 60, right? Because, basically the question was if you have a regular 6-sided die, we know the probability that you roll a 2 is 1 out of 6. And then if I said, okay, well, then you're going to roll it 60 times. How many 2s would you expect to pop up? Well, what we did is we did just 1/6 times 60, and that's how we got 10. Basically, it's the same thought process here. So first, we want to figure out how many are going to buy more than one costume. And it was 10 out of, well, let's see what the total was. It was 10 out of, let's see, it's going to be, doing some quick math, 3, 1, 0. So 10 out of 203. All right. I think I did my math right. This should be 203 if we add all those together. So it's 10 out of 203, but then we're going to multiply that by 900 visitors, and that'll give us our expected outcome. So we'll do, and I get 44.335, basically, about 44.335. The question, it says add round to the nearest whole number. So we would expect 44 people